Every piece of gold on Earth was born in cosmic violence. Supernovae and neutron star collisions are cosmic forges, hotter than anything on Earth. In fractions of a second, they smash neutrons into atomic cores, creating heavy elements like gold. This process is called the R process, rapid neutron capture. And without it, gold wouldn't exist anywhere in the universe. Those newborn gold atoms drifted through space as stardust, waiting billions of years to join Earth. The gold in your ring, your coin, your bar was created in a star's death. This is the beginning of gold's journey. Gold atoms are born in fractions of a second. Inside a supernova or neutron star collision, conditions are so extreme that atoms capture neutrons faster than they can decay. This is the R process, rapid neutron capture, nature's only way to build elements heavier than iron. In milliseconds, brand new gold atoms burst into existence, launched across the universe as stardust. Every gram of gold you've ever seen began this way, created by the R process. This is part 2 of the journey of gold. Continue the story in part 3, from cosmic dust to solar system. Gold once floated through space as cosmic dust. Forged in stellar explosions, these atoms drifted across the galaxy for billions of years. Then gravity pulled them together, forming the sun, planets, and our solar system. Some of that ancient gold became part of Earth, locked deep in its crust and mantle. It's the same stardust that prospectors still hunt today, in rivers, in rocks, and in hidden veins. This is part 3 of the journey of gold. Next, meteorites, Earth's golden delivery. Much of Earth's gold arrived from space, billions of years ago during the late heavy bombardment. Asteroids and comets delivered tons of gold. These impacts enriched Earth's crust, adding to the small amount of gold already here. Without this cosmic rain, most of Earth's gold would be locked away, deep in the core, unreachable forever. Even today, some meteorites contain visible specks of precious metals, carrying the story of stellar explosions. This is part 4 of the journey of gold. Next, why gold is rare. Cosmic math. Why is gold so rare? The answer is cosmic math. Gold can only form during rare events, supernovae and neutron star collisions. Out of billions of stars, only a tiny fraction ever make the conditions for gold's creation. Even then, only a sliver of matter becomes gold. Most atoms become other elements. That scarcity is built into the universe. It's why every civilization treasures gold, because nature barely makes it. This is part 5 of the journey of gold. Next, geology. How Earth's crust concentrated its cosmic treasure. Gold doesn't just appear randomly in Earth's crust. It follows the movements of entire continents. Plate tectonics is the engine that drives gold concentration. Where two plates collide, mountains rise and faults cut deep into the crust. These fractures become highways for hot fluids carrying gold and other metals. In orogenic belts, like the Sierra Nevada or the Abitibi, gold veins form when these fluids cool and deposit their load. At subduction zones, where ocean crust dives beneath continents, magmas rise and form giant porphyry and epithermal systems. These zones often produce not just gold, but copper and silver as well. Even rifts and spreading centers play a role, pulling the crust apart and letting hydrothermal fluids rise. Without the slow motion of tectonic plates, there would be no concentrated deposits. Plate tectonics is nature's blueprint for the mother lode. Picture this: deep underground, water and magma teaming up to create treasure. Gold doesn't just appear in chunks underground. It starts out scattered in tiny amounts trapped in Earth's crust. But when magma cools far below, it releases superheated water loaded with dissolved metals, gold included. These hot fluids shoot upward through cracks, carrying their precious cargo. As they rise and cool, gold and other metals suddenly drop out of solution, forming quartz veins sometimes streaked with visible gold. These hydrothermal systems are nature's refinery, concentrating gold where we can find it. Without them, gold would stay hidden and out of reach. That's how nature makes the mother lode. Am I the only one who didn't realize gold can form this close to the surface? Turns out hot fluids from deep underground do all the heavy lifting. Here's how. Imagine magma deep underground heating water until it rushes upward through cracks faults. As these fluids cool rapidly, often less than 2 kilometers down, gold-silver quartz crystallize out, packing veins with incredible richness. These epithermal deposits can carry visible gold, silver sulfides, striking banded quartz. You'll spot their signature in places like Nevada's Carlin Trend, Japan's legendary Hishikari mine. So, next time you see a hot spring or geyser, remember, there could be hidden gold just below the surface. The Story of Gold, Part 11, Carlin-type gold. Invisible but valuable. Carlin-type gold deposits are unique. The gold is invisible. Instead of forming nuggets or veins, microscopic particles of gold are locked inside pyrite and arsenian minerals. These deposits formed when hydrothermal fluids, rich in gold and arsenic, moved through limestone and other reactive rocks. The chemical reaction between the fluids and the host rock caused gold to precipitate in tiny grains, often too small to see even with a microscope. Discovered in Nevada in the 1960s, Carlin-type deposits turned the state into one of the world's top gold producers. Today, mines like Goldstrike and Cortez extract millions of ounces from these invisible deposits, proving that sometimes the richest gold is the hardest to see. I bet you didn't know most of the world's gold comes from hidden giants called porphyry systems. These monsters are changing the gold game in ways you'd never expect. So, what's a porphyry system? Imagine magma slowly cooling deep underground. As it chills, it releases metal-rich fluids that seep through huge amounts of rock. The result? Massive deposits, think billions of tons packed with copper, gold, silver. The gold here is tiny, often microscopic, and there's so much ore that it adds up fast. Famous mines like Grasberg in Indonesia, Bingham Canyon in Utah are classic porphyry giants, pulling out millions of ounces of gold every year and huge copper output too. The gold grades might seem low at first, but the scale is absolutely epic and profitable. That's why porphyry systems are among Earth's most important gold sources. Rivers don't just flow, they hunt for treasure. Here's how gold becomes river gold. Placer gold is the classic treasure. Flakes, nuggets. You find them in streams, but how does it get there? Deep underground, gold forms in veins. Over thousands of years, wind, water, time, these forces break those veins apart. Gravity takes over, carrying heavy gold downhill where it settles in riverbeds. Because gold is so dense, it sinks, nestling into cracks, riffles, natural traps, while lighter stuff washes away. Rivers act like giant sluice boxes, quietly concentrating gold alongside black sands. California Gold Rush, the Klondike. These placer deposits led prospectors upstream, always searching for the mother lode. Placer gold is nature's way of saying, dig here, there's more to find. This is why you need to look beyond the obvious. Sometimes the richest gold isn't in the river, it's above your head, buried deep below your feet. Not all placer gold sits in modern streams. Bench placers form when old riverbeds get stranded high on hillsides, left behind as rivers carve new paths. These benches can hold ancient paystreaks, untouched for millions of years. Then there are ancient channels, buried river systems, sometimes hidden beneath layers of lava or earth. Prospectors in California and Oregon uncovered these gold-rich channels with hydraulic mining and tunnels. The lesson? The best gold isn't always where the water flows today. It might be waiting in a forgotten river just out of sight. Are you afraid you'll never find gold in the desert? Or maybe you think dry landscapes mean empty pans? Well, think again. Desert placers are hidden stashes of gold left behind by ancient rivers long gone, but their treasures remain. But with no streams to sift, miners had to get creative. Enter dry washing, a method to separate gold without water. Wind helps lift lighter sand, letting gold fall out. Vibration shakes finer material, concentrating heavy gold particles. Picture this, old-timers with homemade dry washers, kicking up dust, watching for that telltale glint. It's hot, it's gritty, but when gold appears, every grain is worth its weight in sweat. Even today, prospectors hunt desert washes after storms, hoping for nuggets revealed by rushing water. So if you think gold hunting is just for rivers, think again. The desert's got secrets of its own. Who knows? The next big gold story might be yours. What I wish I knew before gold panning. Sometimes the gold didn't start anywhere near where you find it. The secret? Glacial highways. During the Ice Ages, massive glaciers scraped across the land, ripping gold right out of bedrock. As they slid along, these icy giants carried gold for up to hundreds of kilometers, mixing it into gravel as they went. When the ice finally melted, it dumped all that gravel, called glacial till, across Canada, the northern US, and Scandinavia. That's why prospectors still hunt these ancient deposits today. So if you spot gold far from any obvious source, remember, the ice brought it there, and meltwater streams helped concentrate the gold even more. This is gonna blow your mind. A handful of gold flakes launched one of the wildest migrations in history. The California gold rush changed everything. It all started at Sutter's Mill when gold was spotted in the river. Word spread fast. By 1849, hundreds of thousands, known as 49ers, poured into the Sierra Nevada panning sluicing in hopes of striking it rich. Towns mushroomed overnight, but it was often shopkeepers and suppliers who cashed in, more than the miners themselves. The gold rush built cities, drove migration, and turned San Francisco into a boomtown. Even if most left empty-handed, the dream of gold and the legacy of the rush still shines today. If you love stories of adventure and survival, you need to hear this. The Klondike gold rush changed everything in the frozen north. In 1896, gold was found in Canada's Yukon Territory. The news set off a frenzy. By 1897, thousands of dreamers trekked north, battling the brutal Chilkoot Pass, freezing cold and hunger. They carried heavy supplies, chasing the promise of fortune. Dawson City exploded overnight, turning into the beating heart of the Klondike rush. Millions in gold were pulled from the earth. But the real story is the human spirit. People risking all for a chance at something more. The Klondike cemented its place in mining history, proving just how far we'll go for gold. The Australian gold rush was massive. Imagine stumbling on a gold nugget heavier than your whole backpack. Gold was discovered in Victoria, New South Wales. Suddenly, thousands of prospectors from all over the globe rushed into the Australian outback. The biggest jaw-dropper, the welcome stranger nugget over 2,200 ounces, still the largest alluvial gold nugget ever found. These rushes didn't just make fortunes. They transformed cities like Melbourne, sparked waves of immigration, and put Australia on the map as a land of treasure. Rivers don't just flow, they hunt for treasure. Here's how gold becomes river gold. Placer gold is the classic treasure. Flakes, nuggets. You find them in streams, but how does it get there? Deep underground, gold forms in veins. Over thousands of years, wind, water, time, these forces break those veins apart. Gravity takes over, carrying heavy gold downhill where it settles in riverbeds. Because gold is so dense, it sinks, nestling into cracks, riffles, natural traps, while lighter stuff washes away. Rivers act like giant sluice boxes, quietly concentrating gold alongside black sands. California gold rush, the Klondike. These placer deposits led prospectors upstream, always searching for the mother lode. Placer gold is nature's way of saying, dig here, there's more to find. This is why you need to look beyond the obvious. Sometimes the richest gold isn't in the river, it's above your head, buried deep below your feet. Not all placer gold sits in modern streams. Bench placers form when old riverbeds get stranded high on hillsides, left behind as rivers carve new paths. These benches can hold ancient paystreaks, untouched for millions of years. Then there are ancient channels, buried river systems, sometimes hidden beneath layers of lava or earth. Prospectors in California and Oregon uncovered these gold-rich channels with hydraulic mining and tunnels. The lesson? The best gold isn't always where the water flows today. It might be waiting in a forgotten river just out of sight.